Alright, so last video we talked about the nucleophilic aromatic substitution, right? And so this video we're going to look at the mechanism of it. Right, so first things first is, the OCH goes, replaces the Cl, which is a leaving group, so we know that this has to leave. So the first thing that happens is that, nucleophile attacks electrophile. Right, so a nucleophile attacks the electrophile over here. Right, and we know that, this benzene right now is electrophilic because of the NO2, which is very electron withdrawing.
So does it mean that only in the presence of an NO2, a very electron withdrawing group here, this will persist?
Yes, and that's because if you see the mechanism, what happens is that we have to redraw NO2.
Right, you got to draw the stick and cross model by showing all the bonds.
Yep. And so what happens is this arrow gets pushed up, this arrow gets pushed up, and this arrow gets pushed up.
Oh, which means that even before the existence of the nucleophile here, this can so-called self-resonate and therefore causing this carbon that's attached to chlorine maybe slightly positively charged.
Yeah.
Which is prone to a nucleophilic attack.
Yes, and that's why without the NO2 or any other electron withdrawing group, this reaction cannot happen.
Lovely.
Right, so after we do this, what we get is, we get the same 6-membered ring.
6-member ring, and then we have this sp3 hybridized carbon right in the intermediate.
Yep. And so what we have is something like,
So this is stable, it can be isolated.
Right. Alright, so this is what we have now.
It has a net overall negative charge. Yeah, because you have 0 charge, incoming -1, overall -1.
Yep. And so the last thing we need to do is we have to kick the Cl out, right?
Right.
So the electron that went up,
Plus. Right.
oh, right.
Okay, can.
And the electron that went up now will come back down. Right, so what we do is,
The lone pair, yeah?
the lone pair move, we push, and Cl leaves.
Oh, and kick out. And can I draw a final arrow here?
Alright.
Is it possible?
Yes.
Dun, 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 dun. Voila.
Alright, so this was the reaction for the nucleophilic aromatic substitution of the benzene ring. Alright, so see you next time.